Welcome to the third Unity session for Warwick Game Design. In this session we are going to be making a very simple first-person shooter game. Now this is actually a re-recording since the live session that we did, we lost the audio for it. So I'm going to try and rock it through the whole thing. This might be slightly different to the version that was done live, but you'll get the general idea of what we did. We are going to start by giving the player somewhere to kind of stand on. And one of the best tools to do that is actually built into Unity, but it's built into the package manager. So if you go to Window Package Manager, it brings up this this window here. Now the package manager contains a load of packages that aren't loaded into Unity by default, but are available to anyone to use. And the one we're going to look for is called ProBuilder. So if you find ProBuilder in the list, you'll need to make sure that you don't have in project or my assets or built-in packages selected. If you have Unity registry or all packages, I think it's in some versions, and that will bring up every available package. Select ProBuilder, and the current version is okay. You can click to see all versions, but we can just go with the default, and then click install, and that's going to automatically install the ProBuilder package. Now, ProBuilder is a tool for blocking out levels, so rather than using an external tool to model a level or using Unity primitives, this is a very flexible and easy to use tool for kind of prototyping levels. I mean, in some cases, depending on the type of game you're making, you can just use ProBuilder to build the final levels of your game if you're going for a kind of prototypey looking aesthetic, I suppose. But for most cases, you'll just use ProBuilder to get a basic gist of what your level's geometry will look like. And we're just going to do a very, very brief overview of ProBuilder as a prototyping tool. I'm only going to make a very basic kind of floor for the character. So to use ProBuilder, if you go to, I think it's Tools, ProBuilder, and we bring up the ProBuilder window, and this brings up a bunch of tools for us to use. If I'm going to dock this next to my inspector. Now, the first thing we'll want to do is add a new shape using this button. And you can select which kind of shape to add. So, you can add a cube, you can add a door, a cylinder, an arch, but we're just going to add a cube because it's the easiest one to work with. And then we select build. Now, you will notice that now that we've got ProBuilder added, we have these extra tools up here. You'll also notice that the lighting is completely wrong, so I'm actually going to go to lighting, and I'm going to auto-generate lighting, and it's just going to make our cube look, more natural like that. We'll go back to ProBuilder. So if I select this cube, you can see the first handle here is kind of highlighted, and this is for object selection. These buttons are kind of similar to the ones you get over here, but they're specific to ProBuilder. So if we were to select Vertex selection, instead of selecting the whole object, we select a corner of the object. Similarly, if we select edge selection, we select an edge, and face selection selects an entire face. Now this is kind of nice, but we want to do something with these faces, these edges, and these vertices. Now if you've used modeling software like Blender before, you'll see where I'm going to be going with this, but basically we can add faces and vertices and edges to this mesh to build out something more impressive. So first of all, I'm actually going to recenter this whole thing, so it's currently off center. I'm just going to go to the cube, it's called cube, go to its transform, and I'm going to click reset to put it back in the center of the world. And to start off with, I am going to extrude a face from here by going to Extrude Faces. So if I press the plus here, it brings up this dialog, and there's options for how to extrude, but I'm just going to go to face normal, and it's going to extrude along the Z here of the face. And I'm going to extrude by, let's say, 1, I think? Yeah, we go. So this is extruded by 1 Unity unit outwards. Now, if I want, I can actually just move a vertex or a face using the similar Unity controls that we've been using for moving things around so far. So if I were to select this, I can, move the face, but that doesn't add new geometry. That just moves the face rather than adding another face, another set of faces. And sometimes when we're building levels, we don't want to just move a face, we want to add more. So I'm going to kind of extend this outwards just by moving the face. Then when I get to here, I'm going to extrude another face. And now we've got, you know, one face here, one face that's very, very long here, and then another face here. And this is in fact a whole 3D object, so it's extruded all of the faces. And then I'm going to select these. So to multi-select, it's the same as in Unity. You just select one of them, hold Shift, and then select the rest. And I'm going to extrude again, and drag out yet again to about maybe there. I'm going to extrude again, and that's going to give us this kind of shape here where the center is one really big face, but then we've got these edges here, and that's because I could have taken the first cube and just stretched it all out to this big cube here, but then this big rectangle, this cuboid, sorry, getting my terminology mixed up. But then that makes it harder to extrude walls out, and for this I want to actually have some walls protruding from all but one of the sides. So doing it this way makes it easier to select these three sides and then extrude again. And just like that, we have some walls, which is going to be very useful because it will stop our player from just vaulting off all of the edges. I've left one of them open because it'll be useful for demonstrating some things later. So that's a very, very brief overview of ProBuilder. Next, we are going to build the character controller. So to start off, we are going to need to add a collider for the character. So if we go to the hierarchy, right click, select 3D object and select capsule, this will add the default Unity capsule to our scene. If I reset the transform, now you will notice that the movement controls are actually not visible on this mesh, and that's because with ProBuilder added, we still have these controls up here. So we need to select object selection, and that's going to bring back our normal Unity controls. The problem is, because this isn't a ProBuilder mesh, if I have one of these other ones selected, it'll get a bit confused and not know what to do. So I'm going to kind of like, you know, drag this capsule onto the platform here. And in fact, because we're just building a character controller, we don't want to even render the mesh, we just want the collider. So we can go to the mesh renderer component and deactivate that. And that gives us this kind of green, capture-y looking wireframe. And that's the collider for the mesh. The next step is, of course, to add some physics and some control to this collider. So because it is a character controller, we are going to want to use something like WASD keys to move it horizontally and vertically along the X and Z planes, axes, sorry, along the XZ plane. But we're going to want to use the physics engine to simulate falling on the Y-axis. So the way to do this is, of course, to add a rigid body. So if we go to add component and type in rigid body, that's going to enable physics on this collider. But there's a few things we'll want to kind of tweak on here first. So we can keep use gravity on. We don't want this to be is kinematic. We don't want to enable is kinematic because we want the physics engine to automatically apply forces. That includes gravity. But if we go to constraints, what we are going to want to do is freeze rotation on all three axes. Later on, we are going to be manually modifying one of these rotation axes, I think the Y-axis, but we don't want the Unity physics engine to modify the rotation itself. Freeze rotation doesn't prevent you from manually changing the rotation, it just prevents Unity's physics engine from automatically changing the rotation. And the same is true of position, but we don't want to freeze position on any of the axes. That's it for the rigid body. So we can get started on a script that is going to move our character. So if we go to the project window, right click and go to create C# script and call this something along the lines of player controller. And if we double click this to open up Visual Studio. You might have another IDE installed, but this is the default. It's the one that Unity tries to install when you install Unity. And this is going to give us the blank script template. We are not actually going to need start, so I'm going to delete that. But there are a few things that we're going to need for our script. So first of all, we're going to be using the rigid body to control our movement. So we're going to need a reference to the rigid body, and I'm going to call that RB. If we save the script, come back into Unity, and if we select our capsule, I'm actually going to rename this player. We can attach the player controller script to it. So now we can attach the rigid body, and it's actually attached to this object. So if we wanted to in the script, we could use the start method to just automatically assign this, but it's also as easy to just drag it on from player. So you can either drag the player here onto rigid body, or you can drag the component itself. So now this player's rigid body is assigned to the rigid body variable. What we're going to want to do every frame is calculate the movement along the horizontal and vertical axes as defined in the input manager. We've talked about that previously. And we're going to want to, modify the velocity of the rigid body to reflect the input that the player puts in. So the first step here, of course, poll the inputs. So that's super easy. We can say float x equals input.getAxis, and the name of the axis is horizontal. And that's going to get the input along the, if you're using WASD, that's along the A and D keys. And we're also going to want float z equals input.getAxis vertical. And that's going to get the movement along the W and S keys. Now we're going to want to apply this to the player somehow. And there are several ways of doing this, but the one, we'll go over two ways of doing it. So either we can add a force to the player, and that's going to let Unity automatically work out what the velocity should be. So by adding a force, we're not directly changing the velocity. And the other way of doing it is by directly changing the velocity. So generally speaking, changing the velocity directly gives you more control over the player movement, but adding forces kind of allows a more interesting physics-based play. So if you were building a physics-based game with lots of bouncing platforms and that kind of thing, then you might want to use forces. To use forces, we would go with the methods are called add force. So if we go rb.add force, we need to construct a new vector3, which controls how, which direction to add this force in. So that's super simple. We say new vector3, we say x, 0, z. So the y is going to be 0. We're adding no force on the y. And we're actually going to want to multiply that by a speed variable, which I'm also going to define up here. So public float speed. We can give that a default like 5, but you will want to kind of toy around with this value in the game. And we're going to give it a force mode of force, which is the default, but what force mode.force does is it just applies the force as a force. I know that's a very underwhelming explanation, but the other ways of doing this are acceleration will apply this force to it will continuously add an acceleration. So whereas force takes into account the mass, acceleration does not. Our mass is in fact 1, so force and acceleration in this case will be exactly the same, but that doesn't always work. So if you have something heavy and something very light in terms of mass, force and acceleration will work differently for the same values passed here. Impulse acts to directly change the well, it adds an impulse, so it's a very instantaneous force, rather than being applied over several frames. This is like a very instant force. So an impulse is if you want something to jump, for example, which we will add to this character controller. A velocity change is similar, it just directly changes the velocity. So impulse and velocity change are very similar as well, except impulse takes into account the mass and velocity change does not. So we're actually going to sit with force. And this is going to add a small force to the player controller. So if we go into Unity and let it compile our script, if we keep the speed as something like 5, if we play our game, the camera's actually in a very, very weird place. Oh, and of course we can't even, we can't actually see our character yet. Since this is a first-person character, we're actually going to take a segue here and set it up as a first-person character. Our main camera is currently detached from the player, but we don't want that to be the case. So we actually want to make the main character a child of the player. But of course it's in the wrong position now, so we'll want to take the main camera, reset its transform so it puts it inside the player's capsule, and we'll just raise up the camera a little bit so that it's about roughly eye level. We can probably move it forward a little bit as well. So that gives us a... actually, if we don't move it forward, because sometimes it will look a bit weird when we're rotating. But yeah, there we go. So now if we were to play the game, apologies about that. If we use the WASD keys, our character will start moving around, but they are extremely floaty, and that's what you get when you use forces. The other way of doing this is using velocity changes directly, so we can say rb.velocity equals, and we can do something similar, so new vector 3 x, and instead of doing 0 here, we actually want to say rb.velocity.y, and the third is z, and we'll times the x by speed and the z by speed. We can't put this outside because that would also multiply the velocity and it would look really silly. And if we put a semicolon there, if we try this instead, it will be a lot less floaty. So I prefer this way when I'm building character controllers because I have so much more control over where the character goes. And because I'm modifying velocity rather than position, the physics engine still works, so I can't just like collide through these walls. They do stop me from moving into them. The next thing that we'll want to add is a jump force. So we'll want to add another public variable here. So public float jump force, and we'll give this a default of say 10. And then we're going to want to use the input system again, but instead of doing an axis this time, we'll do a button. So if input dot get button down, and this button is called jump. It's automatically configured by Unity, so there are several of these. So the horizontal and vertical axes are defined by default. Jump is also defined to be spacebar, and I think something else. There's also cancel, which is escape and stuff like that. So we are going to want to add a force to the rigid body. So rb.add force. And this is just going to be a new vector 3. And it's going to be 0 on the x and z, but it's going to be jump force on the y. And instead of being force mode.force, this is going to be an impulse. So we're only going to apply this once when jump is hit, and it's going to just send the character flying upwards. There is a bug here that we've kind of engineered into this, in that we're not checking if we're on the floor before we jump, so we are going to find when we play this game we'll be able to jump infinite times, but that's fairly easy to fix. So I'll leave that as an exercise. I'll leave that as an exercise to the reader. That old meme. Right. So if we go into play mode, now if we hit space, our character jumps. They jump very high, so we're gonna want to decrease that a little bit. So we just go to player and say, we just make that 5 as well. That will probably give us a more sensible jump. There we are. Fantastic. And then the next thing we'll want to do is deal with rotating the camera. So currently we can't rotate the camera at all, and that's very annoying. We are going to fix that now. So, let me think about this. So, we will need a few variables for this. So, we want to control the speed at which we can rotate the camera along the horizontal and vertical axes. And we're also going to want to define a minimum angle the character can look down and a maximum angle the character can look up. Because if we just let the character keep rotating vertically, we'll have a situation where we'll look so far down it will wrap around, and that will look very unnatural. So we're going to say public float look speed horizontal, and we're going to make this 1 by default. Public float look speed vertical. That's going to be 1 by default as well. And we're going to say public float min look angle. And we're going to define no defaults for these because we're going to play around with this in the inspector and kind of gauge what we think is a good value for it. And then public float max look angle. And that's also going to have no default. We are also going to want a reference to the camera so that we can move it. So camera main camera. And finally a variable to keep track of how much we have rotated on the vertical axis, because that's the one we're going to lock. So private float vertical rotation, and that's going to start at 0. This is going to mean we will need to make sure that the camera is not rotated along the vertical by default, but that is the case. So right, to kind of deal with this camera rotation, we'll use the mouse movement. That's going to mean if we use float mouse x it equals input.getAxis, and this is going to be mouse space x. The M and the X need to be capitalized. This is also defined by default by Unity. And float mouse y equals input.getAxis mouse y. And to rotate the character around the x-axis is very simple. All we need to do is get a reference to this GameObjects transform, which every single script has access to automatically just by writing transform. And we're going to say transform.rotate. And we're going to rotate, we can just pass in 3 values here. So if we pass in the X, Y, and Z angles we want to rotate around, we don't want to rotate around the X-axis. We do want to rotate around the Y-axis by the X mouse amount, which is maybe seems a little bit backwards, but if you think about it, we'll rotate around the Y-axis the amount that the mouse moved on the horizontal, so that kind of does make sense. And we're going to times that by the horizontal look speed, and then we want 0 on the Z. And that's super simple. You know, if we were to play this now, we're going to have to assign some references first. But if we... Okay, we'll sort out all this now. So if we attach the player camera here, we'll actually keep the look speed the same for now. So yeah, if I rotate if I move my mouse horizontally, the camera moves horizontally. Now you see another problem is that when I'm pressing W and S, it is in fact not moving how you would expect. And that's because the velocity is being applied globally. We actually need to transform this. So if we say transform dot, I never remember which way round this is. So it's either transform dot inverse transform direction. Well, it's not direction, it's not transform vector, isn't it? Pass this in. If it's not this, it is just transform dot transform vector. And what this does is it takes it from a global vector and it changes it into the local space of the object that it is attached to. That's incorrect, so it must be the other one. Transform vector. Wait for it to compile. Now go to rotate and press W. I move forwards in the correct way. There we go. Just a small fix there. But we can look in the direction that we intend to. Now, you would think that we can just also say transform.rotate along the x-axis to do the vertical look. But the problem with doing this is that you encounter a problem when you try and rotate around the axes. You'll end up with a weird rotation if you're just rotating the same object along two different axes. It's a little bit complicated to explain, but there's a problem called Gimbal Lock, for example, where if you end up rotating, an object such that one of its local axes overlaps with the incorrect global axis, then you try and rotate along one of the other axes, it ends up kind of going wrong, and you end up losing a degree of freedom. So what we do instead is we rotate the parent along the y-axis, and then we rotate a child object along the x-axis. So in our hierarchy, we have the player here, which we're rotating around y, but we're going to take this child object and rotate that around x. And you end up with much smoother rotations. So we're going to say, first of all, vert rotation plus equals mouse y times look speed vertical. Because if you remember, we're keeping track of the vertical rotation so that we can clamp it between the minimum and maximum lock angle. Then we're going to say basically, if vert rotation is greater than the max lock angle, we will clamp it to the max lock angle. So if it's greater than the max lock angle, we'll set it equal to the max look angle and say else if vert rotation is less than the min look angle, we'll do the same thing the other way around. So we'll say vert rotation equals min look angle. And then we need to set that. So rather than setting this on transform, we'll say main camera dot transform dot local rotation equals Quaternion dot Euler, and this is going to be vert rotation 0, 0. Just to briefly explain what's going on here. Internally, Unity represents rotations as Quaternions, which are complicated. So the way that a human person thinks of rotations, you probably think of it as a rotation around the x, y, and z axes, and that's called Euler angles. The problem with that is the gimbal lock that I just explained. Explained really badly, I know, but if you're interested in the problem, then go look it up. It is quite interesting. Quaternions avoid this problem completely by essentially representing a rotation using more data. It can be thought of as an angle axis system where you define an arbitrary axis and an arbitrary rotation around that axis, and that can be used to describe the rotation. But it uses basically 4 components, and it's all with really weird maths. But the nice thing about the class is that we can say Quaternion.Euler and pass in an Euler angles representation, and Unity will build the rotation for us. So we don't need to worry about working with Quaternions under the hood because they are horrible. But we don't need to worry about them. So if we go back into the into scene view and then go into play mode, ideally, right, okay, no, this won't work because we didn't change our min and max lock angles. So I'm going to say the min angle will be, say, -75, and the max will be 75. And this is going to mean that we can't look too far down on the X, and too far up on the Y. Not on the X, sorry. We can't look too far down and too far up vertically. As it turns out, this is kind of inverted, so what we can do is we can say minus equals here. And that works more like how I expect it to. Yeah, so that's a preference here, but if it is inverted for you, then on this line here, where we set vert rotation initially, change the plus equals or the minus equals to something else. Obviously, I don't think I said this at the time, but plus equals basically just takes the value of vert rotation and then adds this to it and assigns it back to vert rotation. Or minuses it in this case. So that is our character controller. That is pretty much done at this point. Now we can worry about shooting things. Obviously, this is a first-person shooter. So the first nice thing I think we'll do is, rather than just having the player not hold a gun, it's a first-person shooter, they've got to hold a gun, right? So we are going to go to the asset store and find a gun model. Now, I did find one earlier. We found one during the live session, so I'm not going to search for it here. But basically, if you just type in, you know, gun model or something. If I can type, that would be fantastic. So, you know, something like gun model, wait for it to load up, and then you just go, you click this button, free assets, and find a nice model here. And I can't remember which one we picked, but if I just go to my assets, and I'm going to find the one that I used last time. Yeah, this one here. So it's just called Sci-Fi Gun Light. So I'm going to click the import button and make sure everything's selected here. If I didn't want to include everything, then I can unselect things. Actually, I will do that. I'll unselect the scenes folder because I don't want to import a big scene. And then if I click import, it's going to automatically download the package and put it in my assets folder. It's very helpful. Very automatic. And that's done now. So if I go to scene, and if I take the model, actually the prefab, expand this to gun light, and we'll take one of the nice ones, and we're going to make that a child of the main camera, and then reset its position. And if we now separate out the game view here, we can see how it will look. And there are going to be a few problems here. So if I just reposition this somewhere a bit nicer, somewhere like here, if I rotate it a little bit, you will already notice some problems insofar as it's not rendering the whole gun. And that's because on our camera, the clipping planes, which you can see here, is the near clipping plane is too high. So a clipping plane is essentially anything that the camera can't see because it's too close. So this kind of frustum here, frustum is just like a square or a rectangle based pyramid with its top cut off. This part of the frustum kind of defines anything closer to the camera than this rectangle will not be drawn. So this part of the gun backwards is being ignored by the renderer. And we can change this by decreasing the near value here. So I think that 0.1 is gonna make us able to actually see the whole gun. 0.3 was too high. And the same is true of the far clip plane. That is the big rectangle way in the distance there, but we can keep that as 1000, that's fine. Now if we were to play the game, we'll encounter a new problem. Or ideally we encounter a new problem. No, evidently not actually. This is being okay. Sometimes, you know, if the gun is like a little bit more forward, the gun is more forward, so I don't know why you'd have it here, but yeah, you get this problem where the gun model intersects with objects in the scene. Normally in an FPS you don't want this to happen, so what we're going to do is add another camera. And there's this trick where you add a camera and you get it to render only the gun, and the main camera renders the rest of the scene except the gun. And to do this, we need to use the layering system in Unity. So the main camera by default is rendering everything. If we go to Culling Mask, this defines which layers this camera renders, and everything is selected, so it will render everything. However, we are going to go to the gun, we're going to go to Add Layer. I'm going to call this, we'll just call it gun. You can call it something like overlay or, you know, that kind of thing. Go back to the gun and assign that layer to this object. Now the gun is in the gun layer. What we can do is, if we go to Culling Mask, if I turn off the secondary camera just to illustrate this, if I go to the main camera, go to the Culling Mask and tick off gun, it disappears from the game view. That means that the main camera is no longer rendering the gun. However, if we add this secondary camera, its Culling Mask is currently everything, and it's being drawn over the main camera. So the camera ordering, basically cameras will render in sequence after each other and overlay their rendered image over the previous camera's rendered image. And the order it does this is determined by depth. So the main camera always has a depth of -1, or by default it has a depth of -1. That means it's rendered first. Cameras with higher depths are rendered over ones with lower depths. So this secondary camera has a depth of 0. That's what we want. But we want to turn off rendering most things. So first of all, we will change the clear flag to depth only, and that means it won't modify, well, it won't try and draw a skybox or any sort of colors over it. It will only use the depth information from the previous camera's rendering. And that's important because we want it to clear the depth values so that it removes the problem that we had before of it rendering over. It's a little bit complicated, but basically the depth information is the bit that was causing Unity to ignore parts of the pixels of this gun. If we clear the depth values, that means this secondary camera doesn't know how far away these walls are from the camera, and it will go, oh, okay, well, this isn't, this part of the gun isn't being obstructed by anything, so I'll just draw it. If we went to don't clear, it would still have the same problem we had before of not drawing part of the gun. So make sure this is depth only. And then we're going to go to the Culling Mask, select nothing, it's going to remove the gun again, and then select gun and it will re-put it back. And we're going to want to change the near clip plane again just to make sure we render the whole thing. Now if we were to play, if we walk up to this wall, we'll see it doesn't intersect at all. So that's just a neat trick that you can use if you're having problems in an FPS where your gun is, or not necessarily gun, but anything else is not rendering properly. We actually see the camera preview for just the secondary camera here is only the gun. That's what we want. Now we're going to deal with the gun actually firing. So if we go to the project window, if we go to create C# script and call this gun controller, open this script up. Oh, small thing about the cameras is it does come with an audio listener, and you're only meant to have one of these in a scene. So if we just go to the secondary camera and remove that, the audio listener is just basically a pair of ears in the scene. It only ever makes sense to have one. So we actually don't have audio in this game, but I thought I'd just point that out. Yeah. So the gun controller is going to want to pull for the player pressing the shoot button, and when the player does that, the gun needs to raycast forward to detect if something is in the view of the player. So if something is on the player's crosshairs, it needs to detect that and make something happen. So it's going to fire a bullet in that direction. There's two ways of doing bullets and shooting, or two main ways. The first way is using projectiles. So that's when you have a prefab that you instantiate in the scene and give it a really fast velocity forwards, and let the physics engine calculate when that bullet intersects with things. And that's great if you want to add stuff like bullet drop, more advanced forces to the bullet as it's traveling. However, bullets move very fast, so you can end up with some kind of significant errors with this technique if you don't do it right. The second way of doing it is using raycasts. Now, a raycast basically points forward in the scene and says, here's this imaginary line, and if anything intersects with this imaginary line, I want you to detect that, and we'll do something at the point of intersection. And we're going to do the Raycast method. And to do this, we again don't need the start method. We need a reference to the camera, the main camera, because that's where we're going to be raycasting from. So if you say public camera. Oh god, I'm really messing up my typing today. Main camera. We're going to assign that in the inspector. For now, that's all we'll need. And we are going to say if input.get button down fire 1, which corresponds to the left mouse click. Now we're going to build what's called a ray. So a ray is, as I mentioned, this conceptual line that has an origin point and a direction. And it's basically equivalent to me standing here in a position and then pointing in a direction and saying, the first thing that I hit, the first thing I'm pointing at that I can see, that's what I want to detect. So we'll say ray r equals new ray, and we're going to give this the main camera's main camera.transform transform dot position. So it's from the main camera's position, and we're going to want to point forward relative to the main camera. So that's main camera.transform.forward. And then we're going to want to create a data holding object, which we pass in to the Raycast method, and it outputs data about the raycast once it's completed. So this is going to be a little bit different to how we've used methods in Unity before, because this is an object we pass in and it gets changed by the method and output. And there's some special syntax for this. So if we first of all create, it's called a raycast hit. We'll call it hit. We'll initialize it here. And then we say if physics.raycast, we need to pass in the ray, and then we'll say out hit. And this is just saying that we will input the hit object, but we want it to also be modified and output. So it's different from a return value because the return type of physics.raycast is a boolean. That's why we're saying if. This boolean is false if the raycast does not intersect any objects, and true if it does. But we can't return multiple things, so this is a kind of a trick to get around that. So we're returning a boolean, but we're also modifying this hit struct. I think it's a struct, yeah, this hit struct, but we want to access it afterwards, which is why we use the out keyword. So we're basically going to say, yeah, if physics.raycast, we're going to want to do something when we hit something. So we can access the hit point, and we will do. We're basically going to add a very small placeholder sphere in the position that we hit, just so we can visualize what we hit. So we can say GameObject decal equals GameObject dot create primitive, and then we pass in a type of primitive here. So a primitive in Unity is something like a cube, a sphere, a capsule, everything that was under that small list of objects that you can add. So primitive type dot sphere. That's going to create a sphere. We want to destroy the collider of the decal, just because we're going to be adding a sphere and it comes with a collider to begin with, but we don't want to actually let our character collide with it, because that would be really silly. It's just for visualization. So we're going to say destroy decal dot get component Collider. I think you can also use decal.remove component, but I just want to illustrate this destroy method, which you can pass in any Unity object here, and it will automatically remove it from the game completely. We also want to say, decal.transform.position equals hit.point. So hit.point contains the exact location of the intersection of the raycast with an object in the scene. So if we shoot the wall, it will give us the point at which the raycast intersected the wall. And we're going to want to say decal.transform.local scale is something really tiny. If we say divide equals 10. And this is going to add a tiny little sphere everywhere we click. Now, because we're using the main camera's position and forward direction, it's actually going to be from the center of the screen. Oh wait, didn't attach the gun controller. So on my gun, I'm going to attach the gun controller script and attach the main camera to its main camera variable. I'm going to try that again. As I left click, you'll see that a sphere appears, a tiny little sphere appears in the middle of my screen where I'm clicking. We are actually going to want to remove those over time. So we don't want them to just exist forever. So a very easy way to do this is, create a new script called Decal Timeout. We'll just open the script up, and we don't need update. All we're going to say is, well, there's actually several ways of doing this. I'm going to do this a different way than we've done things before. So I'm going to add another method called void remove decal, or something along those lines. And in this method, all we say is destroy game object. So destroy game object is going to destroy the thing this script is attached to, and the script itself, and all other components attached to that object. And in void start, we are going to say invoke. So the invoke method says call this function in some amount of time, and then we pass in a string that represents this like the method name as a string, and comma, we put in a time. So we might say 10, and that's going to call this method in 10 seconds from the start of the game. That's all we need for this script. We just want to destroy the decal after 10 seconds. Super simple. And we are going to need to add that. So several ways of doing that. We could make a prefab of a bullet, of a decal, sorry. But since we were using create primitive here, it's much easier if we just do decal.add component, and we'll add the decal timeout script here. That's just going to add a timeout mechanism to every bullet that we create, every decal that we create. Now if we were to play, and if we were to wait 10 seconds, we'll see that these decals start to disappear. Any second now. There we go. So the first one just bopped out of existence, and the rest of them follow suit. That's good enough for me. Right, now that we've got decals out of the way, we need a target to shoot. So very, very quickly, very, very simply, we are going to add a 3D object, a sphere. I'm going to reset its transform. I'm going to put it kind of in the middle of the scene, and I'm just going to kind of stretch this out. So if I take the scale tool, scale it slightly upwards, I'm going to make this look like a balloon. So the idea is we're going to have some floating balloons, and we want to shoot them out of the sky. So the sphere collider doesn't work for this because it's still trying to be a sphere, even though it's now an egg shape. So we're going to use a mesh collider instead. If we go to mesh collider, we can't see it yet. If we tick convex, then we can see it properly. There we go. And I'm going to add a cube to that. I'm going to make it really, really tiny. like that, and we're going to move it down. And now we have the world's worst balloon. And we also add a material for that, so if we go to create material, call that balloon, and we'll make this kind of maybe pink, and add that to both the sphere and the cube for this balloon. We rename it balloon, and we're going to make this a prefab. So if we take balloon here and we drag it down here into the project view, we can just delete the balloon. There are a few things that we need to do on this balloon actually. To make sure that we shoot the correct thing and do something only when a balloon is shot as opposed to another object, we're going to use a tag. Now, a tag is different from a layer because we can just easily add any number, like we can add a string tag here. So if we say balloon, go back here to the balloon prefab and select balloon in the tag list. It's going to allow us to do our raycast, detect which object was hit, and compare that to the balloon tag. And if it is a balloon, we're going to do something. Yeah, so if we go back to our script, and we've got our raycast and we've got our decal here, we're actually now going to say if hit.collider, that's the object that the raycast collides with, .tag equals balloon, and then we're going to say else. So if we hit a balloon, we don't want to show a decal on the balloon because that would look really silly. So only when we don't hit a balloon, we're going to spawn this decal. If we hit a balloon, we're actually going to destroy it. So destroy hit.collider.gameObject. That's going to destroy the balloon. So if we go back into the scene now, we'll spawn in one balloon over here. And hopefully this just works fine and dandy. So I'm going to need to line this up. Yeah, so if I click, gets rid of the balloon, it's dead. The final things we're going to want to add are a way of spawning in new balloons. So if I just delete this one, and a way of keeping track of a score. So this isn't much of a game yet because we can just shoot one thing. We are going to spawn in a few balloons over time. So I'm going to make a new script and call this spawner, and we're basically, before we get going on the script, we're going to add, we call this empty and rename this spawner, and add the spawner script to it. This is going to be a point where a balloon gets spawned from over time, so we're just going to keep the spawn script on there. We'll just have one for now, but we'll copy and paste this into a couple places. So if we open the spawner script, again, we have the start and update methods by default. We do not need update for this. We're going to use something called a coroutine for the spawner. Now, a coroutine, conceptually, if you've used or heard of threads before, it's kind of takes the parallel aspect of that, but it doesn't actually run on a separate thread. Coroutines run on the main thread, but it allows us to run a method over several frames without kind of hacking a solution together in an update. If we do this manually, we end up with really horrible code. So if we want something to execute over several frames, but we just want to call a method for it and just forget about it rather than keeping track of several variables to keep track of its state in update, what we can do is use a coroutine. Now, the kind of way of doing this is to create a new method of type IEnumerator. This is because of the way it works under the hood. Don't worry too much about the naming of this. We're going to call it spawn. It's like any other method. It just has a name and a parameter list. And this has a special return type in it. So, somewhat counterintuitively, we are going to say while true. Now, several of you are probably already like, oh my god, no, you can't do that. But this is actually going to be fine. Normally, if you say while true in a Unity script, everything will die, everything will just collapse in on itself. But by saying while true here, we're basically setting up an update loop of our own, separate from the default Unity update loop. And inside this loop, we are going to create new new clones of the balloon. So actually, we need to come up here and say public GameObject balloon. We're going to say GameObject clone equals instantiate balloon, and we are going to make the spawner its parent, and that's going to automatically position it where the spawner is. So currently this is just going to infinitely spawn things and crash the game, but the magic in coroutines comes when we use the yield keyword. Now the yield keyword defines when this method should halt execution and do something else for a little while. So if we don't have a yield instruction here, well, first of all, it won't compile because it needs to have one. And second of all, if this were just a regular method, it would while true forever and break. But by using yield, we basically tell Unity, stop executing this frame and come back at some point later. And there's several ways of doing that. So we are just going to say yield return new wait for seconds. And this is going to tell Unity to wait for a certain number of seconds before resuming execution. And in this context, resuming execution means it will do the next iteration of the while loop that will spawn an object, then it will yield for a number of seconds, then it will come back and spawn another object, and so on forever. And we're going to wait a random amount of time. So we say random.range, range, and we're going to do this between, say, 3 and 10. I think that works. Unity's random.range is a uniform random number, by the way, so it gives like every value between 3 and 10 has an equal probability of being returned. It's not like a normal distribution. It's not like values in the middle are more likely or anything. So this is going to just wait a random amount of time. There's other ways of using yield as well. So if we wanted to just wait until next frame and not wait any amount of time apart from a frame, we can say yield return no, or yield return new wait for end of frame. But we are going to wait for a amount of time. So this is all we need, apart from, of course, the key thing is we need to actually start the coroutine, and helpfully there's a method called start coroutine. So if we say start coroutine, and then we just pass in a method call, which is a little bit different to what we did with invoke before, where we passed in a string, we actually kind of call the method here. One of the drawbacks of invoke is that you can pass one parameter with the invoke method, but if we had like if we had something like this, then we can't invoke this method. We'd have to have like something like this. So it works the same way as any method call, where you just put in the number of parameters and the type of parameters that it's expecting here. But we don't want anything here, so we're going to leave those blank. Now if we go back into Unity, go to the spawner, and we're going to attach this prefab here. And now it's going to spawn one balloon immediately, and then every 3 to 8 seconds, or 3 to 10 seconds, it will spawn another. There we go, there's another. The next thing we're going to have to do actually is make the balloons move out the way. So a really easy way to do that with the physics engine is to go to the balloon prefab, go to add components, and we'll add a constant force. And we're going to add a force in the... I just realised it has a rigid body, but it's not actually falling, which is strange. We're going to add a force of 9.81, which is going to counteract gravity. I'm trying to work out why it wasn't actually... because it's using gravity. That's odd. So this is 15. This balloon should just be moving upwards. There we go. Oh, I clicked off the game. Oh, I closed down Unity. Excuse me for a second. I'm gonna have to start Unity back up. That was very silly of me. The problem is, when you're working with games in the scene like that, in the game view, it doesn't automatically lock your cursor into the game window, so I just tried to move off to the side and I pressed the X, which is silly. Bear with me for a few seconds. We are back. So we saw that the balloons were moving up like we expect. Now we can add a few spawners around, and it will spawn several balloons over time. So they'll all come up, and then a random amount of time between 3 and 10 seconds, each spawner is going to spawn another balloon. And that's good. That's good. That's what we expect. Now we want some way of tracking a score, and also a way to lock the cursor. So if we just go to the gun controller script and say void start, and we say cursor dot lock state dot lock state equals cursor lock mode dot locked, and also cursor dot visible equals false. Then by default, it is going to lock the cursor to the center of the screen and hide it. So now if I move my camera wildly, I'm not going to accidentally close Unity. To undo that, just press escape and then you can get your cursor back. The final thing we're going to do is very, very quickly add a UI. So I'm going to right click here, go to UI and text. That's going to add a text component to the UI. Now we are going to talk about user interfaces in detail next week, and I say we're going to because we've already done that session. I'm re-recording this session after the following one, so I know that we do go over UIs because we've done it. So next session is about UIs. Very, very briefly, I'm just going to go over very quickly how to do this. So I'm going to position this. Just about there, and that's gonna be an ammo counter, and then beneath that I'll duplicate that, drag it down, and this is going to be a score counter. Perfect. We're also going to add a small image, and that's going to be in the center of the screen. That's going to be very, very small. I'm going to change the sprite because this is going to be the crosshair because we don't have one. And I'll make that red so it's very, very visible. So now we can see where we're actually shooting because we couldn't really before. And very briefly, you'll see that the canvas is actually incorrect. I'm going to go to screen space camera and drag the main camera here. Don't worry about this too much. We do go over UIs in the next session. So that's just going to put the... apparently it's going to put it in the wrong place. That's very annoying. Oh, sorry, if we go with scale with screen size and put the reference size to the size of my screen, it automatically moves things around, which is very nice, so I'm going to put them over here. Going to make them both bigger as well. There we go. And now if we play the game, everything looks good. Now I think about it, I'm actually going to put this on the secondary camera because I think that's no, I'm not. Yeah, okay, that's fine. What are we to now? Right, so we are going to want to interact with those UI elements. So when we're firing our gun, we want to keep track of an ammo count. By default, we're going to have 10 ammo, but we're going to be able to run out. So we're going to have to reload if we run out. So we're going to add another thing here to say, if input.get key down, rather than using the input axes defined by Unity, we're going to just read a key directly. And we're going to say keycode.r ammo equals 10. And then every time that we fire, we'll say ammo minus minus, and this just decrements the value of ammo. So if this is 10, after calling this, it becomes 9, so on and so forth. Then we're also going to check if we have hit the fire button and ammo is greater than 0. I said float ammo, I meant int ammo. It's going to check if we have enough ammo, or any ammo, and that's only going to allow us to fire if we have enough ammo. Now, to display this on the UI, we need to, first of all, using Unity engine.ui, it's not included in the base Unity engine namespace. We need to add this. So that gives us access to UI elements, and we'll say public text, and this is going to be ammo text. After we've modified the value of ammo, at the end of this method, we're going to say, or the end of update, we'll say ammo text. That's the text object. Dot text gives us the actual text string it's displaying. Then we're going to say equals ammo colon space plus ammo. And we're going to do something similar with the score. So when we hit the balloon, we will increment the score. So we're going to say private int score equals 0 by default. We start with nothing, and we need a reference to the text object for the score. So score text, and we are going to increment the score. So that's plus plus. It's the counterpart to minus minus. If score is 0 and we call this, it becomes 1. If it's 10, it becomes 11, and so on and so forth. Once we've incremented the score, we will modify the score text. In the same way here, we'll say score text.text equals score colon plus score. Now if we go back into Unity and hook all these things up, so let's find our gun controller where we put all those things. And we're going to drag on, I think the ammo score is this first one, and the ammo text is the first one, and the score text is the second one. I'm going to rename those, so ammo text, and score text. And if we were to play the game now, fingers crossed all of that just works seamlessly. Ooh. There we go. Our ammo and our score is working perfectly. When I run out of ammo and I try and shoot one of these things, it will not let me. I have to reload by pressing R. And yeah, so that's how you can create a very, very simple FPS game in Unity. So we've done a lot today. We've worked with ProBuilder, very, very briefly. We've worked with the physics system. We've worked with Raycasts. We've worked with coroutines. We've spawned things in. We've used the asset store. And we have built a very simple UI and a very simple game around this basic FPS concept. Thank you for watching. We hope that this was informative. And as I mentioned, the next session, which should be live around about the time this one goes live, is about user interfaces in Unity. Thank you for watching.